तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Last few classes we were discussing about the wastewater treatment by aerobic processes. We have seen both suspended growth systems as well as attached growth systems. Today we will start the anaerobic wastewater treatment processes. So, it also include both suspended growth systems as well as attached growth systems. So, what is an anaerobic treatment system? We have discussed what are the different types of treatment or what are the different type of processes based upon the electron acceptors present. In aerobic system, what is happening? Molecular oxygen will be present in the system. So, the electrons whatever is released from the organic matter will be undergoing a series of oxidation reduction reactions, and finally molecular oxygen will be accepting the electrons and water will be formed. But in anoxic system, molecular oxygen will not be present, but inorganic oxygen in form of inorganic compounds like nitrate, sulfate, etc. will be present. So, these compounds, this nitrate, sulfate, etc. will be acting as the electron acceptor. But in anoxic system also electron transport system is present. But in anaerobic process there is no electron transport system involved, or there is no oxidation reduction reactions taking place, or the energy generated in the system is not by oxidation reactions, it is by substrate level phosphorylation. So, that is the major difference between aerobic system and anaerobic system. Here molecular oxygen is not present at all, and substrate itself is acting as the electron donor and electron acceptor, and substrate itself will be getting reduced to methane and a portion is getting oxidized to carbon dioxide. So, we will see what are the different suspended growth systems and attached growth systems commonly used in anaerobic processes. They are anaerobic suspended growth systems include upflow anaerobic sludge blanket, and this is another attached growth system, upflow and downflow anaerobic attached growth, then fluidized bed attached growth system, and anaerobic lagoon is an example of suspended growth system, and membrane separation anaerobic process is an attached growth system. Now, we will see what are the advantages of this anaerobic system. Anaerobic system is having many advantages over an aerobic system. The major one is it requires less energy. The reason is in an aerobic system the oxidation of organic matter is taking place by the help of oxygen. So, whatever is the organic load in the wastewater, corresponding to that one we have to supply air or oxygen. So, the oxygen supply to the system involves lot of energy. We have seen this in detail when we were doing the aerator design. But in anaerobic system no oxygen is required, the substrate itself will be undergoing oxidation and reduction. So, no need of any external supply of oxygen. So, definitely the system energy requirement is very less compared to aerobic system. Moreover, here since the aerobic process is much more efficient compared to anaerobic process, what I mean is the energy generated by oxidative reduction process is much more compared to the substrate level phosphorylation, which we will discuss in detail when we talk about the anaerobic metabolism. So, because of this one the sludge generated in aerobic system is much more compared to anaerobic system. Moreover, the sludge generated in anaerobic system is in the stabilized form which does not require any further treatment. So, sludge handling is not a problem in anaerobic system, and another one is since the sludge generation is very less, the nutrient requirement is also less, because we know that we have seen what is the molecular formula of a biomass, empirical formula. So, each unit requires a particular amount of nitrogen, phosphorus and other micronutrients, but if the total amount of sludge generated is less, then definitely the micronutrients and macronutrients present in the system will be reduced considerably. And second one is, the other advantages are elimination of off-gas air pollution. This means if we go for aerobic processes, lot of carbon dioxide will be released into the atmosphere, and we all know that carbon dioxide also contribute to the global warming. But when we talk about anaerobic system, the byproduct is biogas, which can be used as an energy source. So the air pollution can be controlled, and moreover it gives rapid response to substrate addition after long periods without feeding. This anaerobic sludge can stay without any food up to 6 months, and even after that, if you add food or supply food to the sludge, it will be activating at a faster rate. But in an aerobic system, the sludge cannot stay without food for longer period. That is another advantage. So this process can be used for intermittent process, because some industries they are seasonal. So in such cases, if you go for aerobic system, what will happen? As long as the wastewater supply is there, the system will be working, but once the wastewater supply is cut off, the system will not be working anymore. But in the next season, when we want to go for further treatment of the wastewater, we have to start the system from the beginning again. But in anaerobic systems, it is not a problem. When the wastewater is not there, the sludge will be remaining there as inactive one, and as soon as you add more and more wastewater, it will be activated by itself. So these are the advantages. But if the process is having so much of advantages, why it is not becoming so popular in our country or worldwide? So definitely there will be many disadvantages for this process. We will see what are the disadvantages of this anaerobic process. The major one is it requires long startup period, and second one is because in the system lot of acidity is produced, addition of alkalinity is very essential, and this process is not able to remove nutrients like phosphate and nitrate. So there is a requirement of post treatment. Just by an anaerobic treatment process, the effluent will not be meeting the discharge standards. So after the anaerobic treatment, we have to go for a post treatment. Mostly it is aerobic process or aerobic combined with other physicochemical processes. Then biological nitrogen and phosphorus removal is not possible. That is what I told here. The post treatment is basically for this nutrient removal as well as the pathogens removal. And the system is more sensitive because the microbiology of the system is very complicated. Not only a single group of microorganisms are present, it is a group of microorganisms which do the work in the system. So the system is very sensitive compared to aerobic system, and susceptible to toxic compounds, and it also produces odorous and corrosive gases like hydrogen sulfide, etc. So these are the disadvantages of the system. So if we can cut down the disadvantages, definitely this anaerobic process will become the treatment option for the future. What are the design consideration whenever we talk about the anaerobic process? It is almost the same as that of aerobic process. We should know the characteristics of the wastewater, because that defines what type of treatment or how much is the time required, etc., and flow and loading conditions, and organic concentration and design temperature, fraction of colloidal and suspended organic material, and wastewater alkalinity, nutrients, macronutrients, inorganic and organic toxic compounds, and solid retention time. So these are the design consideration for any of the biological systems we have already discussed. So before going into the details of the anaerobic process, first we will see what is the mechanism or how the metabolism is taking place in anaerobic process. Because if you want to design a system, we should know how the microorganisms are performing in anaerobic process. Then only we can optimize the system according to our requirement. So we know that because of the metabolism of the microorganism, the organic matter removal is taking place in any biological treatment systems. So that is what I have given here. The mechanism of removal of organic matter is because of bacterial metabolism, and the metabolism is taking place, or during the metabolism the organic matter is used as a source of energy and as a source for synthesis of organic matter. So in both the ways organic matter will be utilized. And we have already seen in the introduction of biological processes, there are three different types of phosphorylations or energy releasing reactions. One is oxidative phosphorylation, another one is substrate level phosphorylation, and the third one is photophosphorylation. So as I have already mentioned, the oxidative phosphorylation is taking place in aerobic processes where electron transport system is present. So it will be undergoing a series of oxidation reduction reactions with the help of enzymes and coenzymes, and oxygen will be acting as the terminal electron acceptor, or in anoxic process nitrate, sulfate etc. will be acting as the terminal electron acceptor. So a lot of energy will be released in such processes. And the other phosphorylation is substrate level phosphorylation. In such systems, electron transport system is not present at all. So here definitely the energy release will be less compared to the oxidative phosphorylation. In anaerobic system, this substrate level phosphorylation is taking place, and it is done by fermentative catabolism. So the specialty of this fermentative catabolism is it is happening in the absence of an oxidant and no transfer of electrons are taking place, only the substrate is undergoing certain changes. So that is the specialty of fermentative catabolism, or in other words, in fermentation process the organic matter itself will be acting as the electron donor and electron acceptor. So we do not have to give any external electron acceptors, and as a result hydrogen gas will be generated in the fermentation processes. So if you talk about any anaerobic digestion, it is a fermentative process and organic matter is getting transformed. The energy released in oxidative catabolism exceeds fermentative catabolism. So this we can show easily using this chemical or biological reactions. We can see an organic matter C2H4O2 when it get oxidized. Okay, in aerobic system the complete oxidation of the organic matter will be taking place with the help of microorganism. So if it is completely getting oxidized in presence of oxygen, you will be getting carbon dioxide and water, and apart from that one we will be getting 207 kilocalories of energy. That means 1 mole of C2H4O2 gives 207 kilocalories of energy if it undergoes oxidative phosphorylation. But if it undergoes anaerobic or fermentative phosphorylation, then what will happen? C2H4O2 will be getting converted to methane plus carbon dioxide plus some energy of digestion. So how can we find out this energy of digestion? What we have to do is, the total energy of the system will be a constant. So we can find out what is the energy released from this methane if we go for complete oxidation. So that is what is given here. We have a mole of methane and it is getting completely oxidized in presence of oxygen. So we are getting carbon dioxide and water, and by oxidizing methane we are getting 191 kilocalories of energy, or methane will be having an energy content of 191 kilocalories, and we know that the total energy of the system will be a constant. So 191 kilocalories of energy is stored by the methane. So what will be the energy of this digestive process or anaerobic catabolism or fermentative catabolism? So we can write like this: energy liberated in the digestive process plus 191 kilocalories will be equal to 207 kilocalories, or the energy released during the digestive process is only 16 kilocalories per mole, whereas in aerobic process or oxidative phosphorylation, for the same 1 mole of organic matter we will be getting an energy of 207 kilocalories per mole. So that is what I have written here. Energy released in fermentative catabolism is around 8% of that of oxidative catabolism. So this is very important. So this is an advantage as well as disadvantage of anaerobic process. The advantage is, since the energy produced in anaerobic process or anaerobic digestion is so low, so if the microorganism have to generate the energy required for their metabolism, they have to use a large portion of the organic matter whatever is available for catabolism. That means if we take the same amount of organic matter, the energy generated here is only 8% of that of aerobic process. So if you have 1 kilogram of organic matter, so the amount used for catabolism in aerobic process will be 8% of that of the one which used in anaerobic process. So what will happen? The most of the organic matter in anaerobic process will be used for the catabolism and only a little amount will be used for the anabolic purposes. So definitely the cell synthesis will be very less, or the amount of sludge produced will be very less. So this is a positive point when we talk about the sludge handling, because the sludge produced in anaerobic process is very less, so we don't have to go for any post treatment. But in aerobic process the sludge generation will be so high, because we have seen that the yield coefficient, that means the biomass synthesis per unit mass of substrate utilization varies from 0.4 to 0.6. So that means if 1 kilogram of organic matter is converted by aerobic process, we will be getting around 400 to 600 grams of biomass, whereas in aerobic process we will be getting only 8 grams of biomass. So the sludge volume will be reduced drastically in anaerobic process. But the major disadvantage of this is, in aerobic process we can maintain a very high concentration of microorganism in the system, because the microbial concentration is very important in any biological processes. The reason is the microorganisms, those are responsible for the treatment. They are the one which utilizes the pollutants present in the wastewater and convert it into environmental friendly byproduct like carbon dioxide, water, nitrogen gas, etc. So if the amount of microorganism present in the treatment unit is high, then definitely the time required for the treatment will be very less. But in anaerobic process what will happen? The anabolism is so less, or the cell synthesis is very less compared to aerobic process. So what will happen? The amount of microorganism present in the system, if you take the same time duration, it will be much less compared to the aerobic process. So the detention time required in anaerobic process will be considerably more compared to aerobic process. That's why in a conventional activated sludge process we need to retain the wastewater only 4 to 6 hours in the aeration time. But when we talk about the conventional anaerobic processes like septic tank or anaerobic sludge digesters, the detention time is around 20 to 30 days. So this explains why we have to give such a long time in anaerobic process. Because of this one, such a long duration is required for the proper treatment. This process was not gaining any attention in the past. The reason is such a long time is required. So you can imagine what is the size of the reactor we have to provide if you want to treat the wastewater, because the quantity of wastewater coming to the system is very large, and if you want to keep that one for 30 days, 20 days, then the volume of the reactor will be increasing considerably. So that's what I told, the catabolism or this metabolic processes, whatever is happening in anaerobic process, it is a positive, it is having a positive effect as well as a negative effect. But how can we overcome this one? Okay, if we can maintain high microbial concentration in the system, we can reduce the hydraulic retention time. So that we will see afterwards. Now we will see how we can apply the anaerobic digestion to sewage treatment. The basic requirement for alternative technology, because we have seen that anaerobic technology is having many advantages over aerobic technology, but okay, that advantages alone will not make it an alternative technology unless it satisfies the following conditions. It should have a favorable stoichiometry, that means whatever the reactions happening, it should be feasible, and it should have a very high removal efficiency, and the removal rate should be very high. If the removal rate is not high, what will happen? We have to give a long time for the treatment, so that is not preferable. Now we will see what are the factors that determine the removal efficiency in an anaerobic system. Those are the nature of the anaerobic matter to be removed, the suitability of the environmental factors for anaerobic digestion, the retained amount of biomass, the design of the reactor system, and the retention time of the sewage in the anaerobic system. So this is same for other biological systems also. If the organic matter whatever is coming to the system, if it is easily degradable, then definitely the treatment efficiency will be very high. The another one is environmental conditions. We have already seen that anaerobic process is very susceptible to change in environmental conditions. So if you can provide conducive environmental conditions, then we can definitely increase the removal efficiency in an anaerobic system. And the third and the most important one is the retained amount of biomass in the system. If we can retain a high concentration of biomass in the system, definitely our treatment efficiency will be improved. The fourth one is how we are designing the system. So we have seen different reactor configurations, CSTR reactors, plug flow reactors and batch reactors. So how we are designing the reactor, based upon that one the efficiency of the system will be increasing. And the last one is how much time we are allowing the wastewater inside the reactor. If you retain the wastewater for long time in the system, definitely the treatment efficiency will be increasing. So whenever we go for any system and if you want to increase the efficiency, we have to consider each and every factor in detail and we have to make our design accordingly. Now we will see what are the microbiology and biochemistry of anaerobic process. As I have already mentioned, it is a very complicated process. That means many reactions are taking place and many groups of microorganisms are involved in this process. So this picture shows the pathways of anaerobic degradation. So you have the organic waste and it consists of proteins, carbohydrates and lipids. So any domestic wastewater we take, it will be containing all these components. So what will happen? As the first step, hydrolysis will be taking place. Then after hydrolysis, the proteins and lipids undergo fermentation. As hydrolysis, the byproduct of hydrolysis is amino acids and sugars, and this will be undergoing fermentation and we will be getting intermediary products like propionate, butyrate, etc. And these lipids will be giving higher fatty acids and alcohols, and these higher fatty acids and alcohols will be undergoing anaerobic oxidation and anaerobic beta oxidation, and you will be getting again propionate and butyrate. Then the next step is acetogenesis, and here we will be getting acetate as well as hydrogen, and this hydrogen is also produced from fermentation pathway as well as this anaerobic beta oxidation. And the last stage is methanogenesis. Methanogen or methane formation can take place from acetate and from the combination of hydrogen and carbon dioxide whatever is generated in the fermentation process. So these are the 6 important steps of anaerobic treatment. That means first one is hydrolysis, second one is fermentation, third one is anaerobic oxidation, fourth one is acetogenesis, fifth one is methanogenesis. This methanogenesis itself can be divided into 2 different categories. One is the methanogenesis from acetate and another one is the methanogenesis from hydrogen. So we will see this one in detail. So this is what I have told. The biochemical steps involve hydrolysis, fermentation, anaerobic oxidation and anaerobic beta oxidation, conversion of acetate to methane and conversion of carbon dioxide and hydrogen to methane. And these 6 steps are carried out by 3 different groups of microorganisms. First one is the hydrolytic and acetogenic bacteria, and another one is obligate hydrogen producing acetogenic bacteria, and third one is methanogenic bacteria. So we will see the role of this bacteria when we discuss the different steps in detail. So first we will see what is happening in hydrolysis process. So we know that the treatment of any wastewater is taking place because of the microbial metabolic activity. So how the metabolic activity is taking place? The substrate has to come and attach to the cell, and it has to penetrate to the cell, and inside the cell the metabolic activity will be taking place. But we know that most of the organic molecules present in the wastewater is very large in size, so it will not be able to penetrate through the cell. Okay, the size of the molecule will be such that it will not be able to penetrate through the cell membrane. So how can the cell take this organic matter? So first what they do, they send some extracellular enzymes or produce some extracellular enzymes. So this extracellular enzymes will hydrolyze the organic matter, that big size organic matter, into small fractions. So in hydrolysis what they do is, the complex organic matter is there, they will be adding water molecule to that one. So that is the hydrolysis process. In the process, the large organic molecule will be split into small fractions. Once it is split into small fractions, it will be easily penetrating to the cell membrane, and once it enters in the cell membrane, it can undergo metabolism. So that is what is happening in hydrolysis. So complex particulate matter is converted into dissolved compounds with the lower molecular weight. So this is happening with the help of extracellular polymers, and in sometimes it can be the rate limiting processes. If it is simple carbohydrates, the hydrolysis will be very easy. But whenever we talk about proteins and lipids, if the wastewater contains more of proteins and lipids, this hydrolysis can be the rate limiting step. Unless the hydrolysis take place, the other process will not be able to take place, because unless it is able to enter in the cell membrane, okay, other process cannot take place. So sometimes, especially the wastewater contains more of proteins and lipids, hydrolysis can be the rate limiting step. So we have to be careful about the nature of the wastewater coming into the system. So whenever we design, so we have to design accordingly. Now the second stage is acidogenesis. So in hydrolysis, in the complex organic compounds are split into small compounds like amino acids and sugars, and the fermentative bacteria will be using this dissolved organic matter in the form of amino acids and sugars, and they will be converting it into volatile fatty acids, alcohols, lactic acid, and mineral compounds like hydrogen sulfide, ammonia, carbon dioxide, etc. So that is the acidogenesis step. Why we are calling it as acidogenesis step? Because of the fermentative process. The amino acids and sugars will be splitting up into volatile fatty acids, lactic acid, alcohols, and other organic acids. So definitely the pH of the system will be coming down at this stage, because lot of different types of organic acids will be generated due to the fermentative processes. So most of the fermentative bacteria present in the system are obligate anaerobes. So this hydrolysis and acidogenesis, okay, this bacteria, most of them are obligate anaerobes, but a few are facultative anaerobic bacteria, which is doing this fermentative process. And this facultative anaerobes, that means the facultative bacteria are those which can survive in aerobic condition as well as anaerobic condition, or they can undergo oxidative phosphorylation as well as the substrate level phosphorylation. So these facultative bacteria are very important in anaerobic processes. The reason is, whenever we talk about the wastewater, the domestic wastewater, it will be open to the atmosphere. So definitely there will be some dissolved oxygen present in the system. So who will be able to take care of this oxygen? Because this oxygen is toxic to the obligate anaerobic bacteria. They will not be able to perform in presence of oxygen. So who will be taking care of the dissolved oxygen present in the wastewater? So the bacteria responsible for that one is the facultative bacteria. So they will be consuming the oxygen and they will be undergoing that oxidative phosphorylation using the organic matter, and all the oxygen remained in the system will be getting removed. So the system will be in complete anaerobic condition, which is conducive for other bacteria. For example, the obligate acetate generating bacteria as well as methanogens, they are obligate anaerobes, they cannot survive, they cannot perform in the presence of oxygen, though they cannot perform in the presence of oxygen, they will not die in presence of oxygen, they will become inactive in the presence of oxygen. Once the oxygen is removed from the system, they will again restart their performance. Now we will see what is this anaerobic beta oxidation. We have seen that after the fermentation we will be getting long chain fatty acids. So this long chain fatty acids has to be converted to acetate for the methanogenesis or for the methane production. So who will be doing, or how this long chain fatty acids are getting converted to acetate or acetate and propunate? That is happening because of this anaerobic beta oxidation. So in anaerobic beta oxidation, the degradation of long fatty acids to acetate and propunate is taking place, and it is a cyclic process. It releases one acetate unit per cycle and it will also liberate hydrogen, but sometimes along with acetate it will be liberating propunate also. It will be depending upon the number of carbon atoms present in the organic matter or number of carbon atoms present in the long chain fatty acids. So that is what I have written here. In the end products are acetate or acetate and propunate depending upon whether the fatty acids are even or odd carbon acids. If it is an even number fatty acid, then you will be getting only acetate, and if it is an odd carbon acid, then you will be getting acetate plus propunate, because we know that acetate is having 2 carbon atoms and propunate is having 3 carbon atoms. So depending upon whether it is having odd number of carbon atoms or even number of carbon atoms, the end product will be changing, and along with this acetate and propunate we will be getting lot of hydrogen H2 from the beta oxidation, and this hydrogen production in a way it is good, because we know that certain methanogenesis bacteria or methanogens can convert this hydrogen and carbon dioxide to methane. But if you talk about this anaerobic beta oxidation, if you see the thermodynamics of the process, it is an endogenic process. That means the reaction is not feasible under standard condition. So what will happen? As the reaction proceeds, more and more acetate and propunate will be generated, and along with that one hydrogen molecule also will be liberated. So the concentration of the product will be increasing. So in any reaction, when the concentration of the products are more, okay, the reaction rate in the forward reaction rate will be decreasing, because we know that what is the reaction rate. So if you want to increase the rate of the reaction, what we have to do? We have to remove the hydrogen atom or hydrogen molecule present in the system, then only the reaction will be proceeding forward. So that is where the help of oxygen, the hydrogen utilizing bacteria is coming into picture. If the hydrogen whatever is generated during the anaerobic beta oxidation can be removed by certain other microorganism in the same rate, then what will happen? The hydrogen ion concentration or the hydrogen molecule or hydrogen partial pressure in the system will be less and the reaction will be feasible. So this is very, very important. If the methanogens are not active in the system, what will happen? This anaerobic beta oxidation will not be taking place, and all the long chain fatty acids will be getting accumulated in the system. So if the long chain fatty acids get accumulated in the system, definitely the system pH will be coming down. Though it is organic acids, any acid can reduce the system pH, but we all know that the methanogens can perform only under neutral condition. So once the methanogens are not able to remove the hydrogen partial pressure whatever is developed in the system, okay, for the production of methane, what will happen? The beta oxidation will be stopped and the system pH will be coming down. So as the system pH will come down, the methanogens will become inactive, because the environment is non-conducive for the system. So what will happen? The system will be failing, or the efficiency of the system will be deteriorating day by day, and we will not be able to retrieve the system at all. So this is known as stuck digesters. So this anaerobic beta oxidation and hydrogen partial pressure in the reactor are very, very important for the proper functioning of the reactor. The reason is, if the hydrogen partial pressure is higher, then what will happen? Anaerobic beta oxidation will not be taking place, and if anaerobic beta oxidation is not taking place, the fatty acids will be accumulating in the system. So the pH will be going down. As the pH goes down, the methanogenic activity will be further reducing. Now the first process is acetogenesis. So we have seen that first the hydrolysis is taking place, and what are the product formed by the hydrolysis? It is undergoing fermentation, and the fermentation byproduct, the long chain fatty acids etc. will be undergoing anaerobic beta oxidation, and we are getting propionate, butyrate and many other products. So in acetogenesis, what is happening? The product of acetogenesis are converted into final product for methane production. The final product for methane production are acetate, carbon dioxide and hydrogen, because the raw materials, whatever the microorganisms used for methane production are acetate, carbon dioxide and hydrogen. So acetogenesis step is the one which convert all the other byproducts of anaerobic oxidation, anaerobic beta oxidation and fermentation to the byproducts which is required for the methane production. And here we can see that acetate is there, carbon dioxide is there and hydrogen is there, and there are many microorganisms which can use the carbon dioxide as well as the hydrogen to form methane, but there are only a limited group of microorganisms which can convert acetate to methane. But if you see the methane formation, around 70% of the methane is generated from acetate and only 30% is coming from carbon dioxide and hydrogen. So the bacteria which is generating methane from the acetate or from hydrogen and carbon dioxide is known as methanogens, and the bacteria which are responsible for the production of acetate and hydrogen are known as acetogens, and the bacteria which are responsible for the hydrolysis and fermentation are known as hydrolytic and acetogenic bacteria. And in these three different types of bacteria, the acetogens and methanogens are obligate anaerobes. Obligate anaerobes means they can survive only in anaerobic conditions, or they will be performing only in complete anaerobic condition, or if you want to maintain the anaerobic condition in terms of EH, okay, in terms of millivolt, okay, it should be in the range of minus 350 millivolts or something like that. That means the dissolved oxygen concentration will be very, very, very low, or it is almost negligible. But the acetogens and fermentative bacteria, some of them are facultative type bacteria. So if some oxygen is present in the system, they will be able to remove that oxygen by oxidative phosphorylation, and the system will be converted to complete anaerobic process. So that is the pathway I have shown earlier. So now this one will be much more clear. The organic waste is coming, which contains proteins, carbohydrates and lipids. So hydrolysis is taking place. In hydrolysis, the splitting up of these molecules are taking place with the help of hydrolytic bacteria, and hydrolytic bacteria are fewer anaerobes, strict anaerobes and fewer facultative type, and this facultative type bacteria are very, very important for anaerobic process, because they will be taking care of the dissolved oxygen whatever is coming in the wastewater. So once the hydrolysis is over, okay, you will be getting amino acids and sugars from proteins, carbohydrates and lipids, and these amino acids and sugars are undergoing fermentation, and you will be getting intermediary products like propionate and butyrate, and the lipids after hydrolysis you will be getting certain higher fatty acids and alcohols. This will be undergoing anaerobic beta oxidation, and you will be getting acetate as well as propionate, and this intermediary compounds whatever is present here, the help of acetogenesis or the help of acetogens, the acetate producing bacteria, it will be getting converted to acetate and hydrogen, and fermentation will also produce hydrogen, acetate and carbon dioxide. So this acetate, hydrogen and carbon dioxide in the presence of methanogenic bacteria, it will be form methane. So this is the complete picture of an anaerobic process. So we can see that so many steps are there and so many different classes of microorganisms are present in the system. So if one step is not happening, so entire reactor will be failing, or if one process is taking lot of time, so the entire process will take lot of time. So that is why the anaerobic process are so complicated, and earlier the biochemistry or microbiology of the anaerobic process were not known. So people were not able to optimize the process. That was one of the reasons why this process was not becoming so popular. So this is the reaction whatever is happening in the methanogenesis. So the methanogenesis can be two different ways. One is acetotrophic methanogenesis. That means the methane production is taking place from the acetate. So CH3COOH is acetate. So it will be forming methane and carbon dioxide. And another one is hydrogenotrophic methanogenesis. That means hydrogen plus carbon dioxide is reacting together to form methane and water. So if you see this acetotrophic methanogenesis and hydrogenotrophic methanogenesis, this acetotrophic methanogenesis is rate limiting, because acetogenesis or acetotrophic methanogens take long time for the regeneration, whereas the hydrogenotrophic methanogens, their regeneration time is very less. So this type of bacteria will be more in the system, so that will not be the rate limiting step, but the acetotrophic methanogenesis will be the rate limiting step in any anaerobic process. That's what I have written here. Acetotrophic methanogenesis is rate limiting, and hydrogenotrophic methanogenesis, because of the high growth rate, okay, you will be having large number of microorganisms coming under this category. So this rate will be very, very high, whereas the microorganism which can form methane from acetate is only a very few. So definitely this will be the rate limiting step. And if you want to see the COD removal in different stages of an anaerobic process, okay, the major COD removal is taking place in methanogenesis. So what is happening? The acetate will be getting converted to methane and carbon dioxide, and another COD reduction is taking place in fermentation. So there what is happening? The electron transfer, whatever is there, okay, it is released as hydrogen molecule. So whatever is the amount of hydrogen liberated, that much of COD reduction is taking place in the fermentation process, or the major contribution of the COD reduction is taking place only in the methanogenesis step. So that's what I have given. COD removal during the acid fermentation is limited to the release of hydrogen, and methanogenesis, here lot of acetate is getting converted to methane. So the maximum amount of COD reduction is taking place in this stage. So the most important problem whatever we face in anaerobic process is the souring of the reactor or the stuck reactor, and we have already discussed what is the reason for that one. The reason is the methanogens are very, very sensitive, and in most of the reactors, anaerobic reactors, this methanogenesis is the rate limiting. And if you want to have the COD removal or the treatment efficiency, the COD should be removed from the system, and COD removal mainly is taking place only in the methanogenesis. So if the methanogenesis is rate limiting or the methanogenesis is not taking place in the system, definitely there will not be any COD removal in the system. So the efficiency of the system will be coming down. So what will happen in an anaerobic system? These methanogens will survive only in neutral pH. That means the optimum pH for methanogens is in the range of 6.8 to 7.6. So if the pH is less than that one, this methanogenic bacteria will not be able to survive under that condition. So what will happen during the fermentation or acidogenesis process and anaerobic beta oxidation? Okay, we have seen that hydrogen molecules will be liberated, and it will be increasing the partial pressure of hydrogen molecule in the system, and the acidogenesis process will be generating so many acids. So definitely if these acids are getting accumulated in the system, the pH of the system will be coming down. So if the methanogens are not working in the same rate, what will happen? These acids will be accumulating in the system, and these methanogens will not be able to survive. So that is what is happening in a souring anaerobic reactor. So that is what I have written here. Acidogenesis, the acid formation takes place, and because of this one the reactor pH drops, and methanogens develop only in neutral pH. The rate of acid removal by methanogenesis falls behind the rate of acid production. The reactor pH falls, which further reduce the methanogenic activity, and this is the most common cause of reactor failure. If you want to control this one, what we have to do, we have to add lot of alkalinity to the reactor, so that the pH change or pH variation in the system can be maintained within the specified limit. So that is very, very important. So we have already seen the metabolism of anaerobic process. So if you want to see the kinetics of anaerobic digestion, okay, we have already seen that the microbial growth rate in anaerobic systems are much less compared to aerobic system, and in anaerobic processes the methanogenesis is the rate limiting step. The major methanogenic bacteria present in the systems are Sarcina and Methanothrix. So this shows the growth curve of Methanothrix and Methanosarcina. So we can see that this Methanothrix is having a mu max value of 0.1 d, that means maximum specific growth rate of 0.1 per day. That means if you want to design a system, okay, and if you want to maintain this microorganism in the system, the biological sludge retention time should be 1 by this mu max value, that means it should be 1 by 0.1, that means 10 days. So if you design a system with a BSRT less than 10 days, what will happen? Whatever the time we are providing, that will not be enough for the regeneration of this methanothrix. So whatever is present in the reactor, it will be washing away from the reactor if the BSRT is less than 10 days. So that is the reason why we have to give a large hydraulic retention time as well as biological sludge retention time in anaerobic systems. If you can retain the microorganism in the system and only the liquid is going out of the reactor, then we can reduce the hydraulic retention time. Otherwise, we have to have a high hydraulic retention time also in the system if we are not able to maintain high microbial concentration in the system. So this also we have already seen what is the difference between aerobic metabolism and anaerobic metabolism. So in aerobic metabolism, the catabolism is only 33%, or whatever substrate we are giving, around 33% is used for catabolism, and for anabolism around 67%. It varies from microorganisms to microorganism. So we can take a range of 40 to 60 or 40 to 70. But when you come to the methanogenic metabolism, the catabolism is around 97% and anabolism is only 3%. So we can imagine what is the amount of biomass getting generated in the anaerobic system. So this is the reason why the methanogenic process is becoming the rate limiting. The biomass generation is so less. So if unless we give a large detention time or large biological sludge residence time, then only we can get a significant amount of biomass in the system, because most of the COD or most of the organic matter coming to the system is utilized for the catabolism or catabolic purposes. Now we will see what are the favorable environmental factors for the anaerobic process. One is temperature. Temperature is very, very important for anaerobic process. The optimum temperature is 30 to 40 degrees centigrade, the optimum being 35 plus or minus 2 degrees centigrade, and if the temperature is below the optimum level, the performance will be coming down drastically, and researchers have shown that for every 1 degree decrease in the temperature, the efficiency will be coming down by 11%, and we can find out what is the digestion rate at any temperature. If you know the digestion rate at 30 degree, we can use this formula to calculate the digestion rate. RT is equal to R30 into 1.11 raised to T minus 30. So this is the temperature dependent reaction, or how the reaction rate is changing with respect to temperature we can make out. From this formula itself we can see this one. For a temperature below the optimum level, the digestion level decreases by 11% per degree centigrade. And here this RT and R30 represent the digestion rate at temperature T and 30 degrees centigrade. this shows the effect of temperature in an anaerobic process. So, we can see that okay, at very low temperature the efficiency, this is the relative digestion rate. We can see that at low temperatures the digestion rate is so less and it is keep on increasing at a constant rate with respect to the temperature, and it reaches a maximum value around 30 degrees centigrade, and 30 to 40 it will be almost a constant, maximum being at 35 plus or minus 2 degree centigrade. So, this is the optimum range, and after this one the efficiency will be coming down drastically. We can see that if the temperature is more than 45 degrees centigrade, the anaerobic reactor is not going to work. So, this is for the mesophilic microorganism, but nowadays people are developing thermophilic and the microorganism which can work under lower temperatures effectively. So, whatever we have discussed so far, we can make sure that anaerobic treatment is best option for tropical region, because in tropical region the temperature available will be almost in all the time, all the seasons it will be around 30-35 degrees centigrade. So, at this time the reaction rate will be maximum and we will be getting maximum efficiency. So, anaerobic treatment is the best option for tropical regions, and pH in the reactor we have to maintain in between 6.3 to 7.8 and optimum pH is 7 to 7.4. And we have seen that the anaerobic process as a byproduct we will be getting methane, and it is having high calorific value and we can use it as a fuel. So, if you want to find out what is the methane generation or what is the amount of methane generated in anaerobic process, we can find out using this equation. We take the methane, and if you want to completely oxidize it in presence of oxygen, what will happen? Methane plus oxygen will give carbon dioxide plus 2H2O, that means 16 grams of methane combines with 64 grams of oxygen, or 1 gram COD is equivalent to 16 by 64 grams of methane, or 1 by 64 moles of methane, or methane gas generated by 1 gram of COD is around 0.35 liters at STP. So, if we can convert 1 gram of COD to methane gas, we will be getting 350 ml of methane gas at STP as per the stoichiometry. And there are different other formula developed by other people depending upon the composition of the organic matter. So, if you have V molecules of C and W molecules of H, X molecules of oxygen and Y molecules of nitrogen and Z molecules of sulfur in the system, and this will be undergoing a reaction with water, and this is the byproduct. You will be getting methane, carbon dioxide, ammonia and hydrogen sulfide. So, we can find out what is the amount of methane produced, what is the amount of carbon dioxide produced, what is the amount of ammonia produced and hydrogen sulfide produced using this equation. V by 2 plus W by 8 plus X by 4 plus 3Y by 8 plus Z by 4, where V, W, X, Y, Z are the number of atoms of carbon, hydrogen, oxygen, nitrogen and sulfur present in the organic matter respectively. And similarly, we can find out what is the amount of carbon dioxide produced and what is the amount of ammonia produced and hydrogen sulfide produced in the system. So, if you want to find out the mole fractions, okay, same equations we can use and we can get the mole fractions of carbon dioxide, methane and hydrogen sulfide in the gas generated if you know the composition of the waste coming to the system. And similarly, we can find out the sulfide production also from the system. If sulfate is there and organic matter is there and carbon dioxide and ammonia is present in the system, then you will be getting hydrogen sulfide and Hs and water, and this hydrogen sulfide and oxygen will combine to form sulfuric acid. So, this is the corrosive gas whatever is generated in the anaerobic system. So, a portion of the hydrogen sulfide is essential for the anaerobic microbial growth, because sulfide is an essential part of the molecular structure, but if it is in excess it will be a problem for the reactor system. Similarly, another byproduct is ammonia, and if the ammonia concentration is excess, okay, that will also inhibit the process. If 2 to 4% of ammonia is present in free ammonia form, okay, it will be inhibiting the reactor, or the toxicity of ammonia in the system is 100 milligram per liter as ammonia nitrogen. If it is present in the ammonium form, it will not be toxic, but if it is present in the ammonia form, it will be toxic, and this ammonia conversion to ammonium is a pH dependent process. So, we will see what all the things we have discussed today. We were discussing what is an anaerobic process and how it is different from aerobic process, and we have seen what all are the advantages of anaerobic process, and we have seen that it is less energy intensive and the sludge production is less, etc. But we have also seen the disadvantages of this anaerobic process, and because of that disadvantages, the anaerobic process was not popular till the recent past. But nowadays what is happening, the microbiology of the process is very clear, and people are able to maintain large quantity of sludge in the anaerobic systems by the invention of hybrid reactors. The anaerobic technology is gaining much more attention nowadays, and we have seen the detailed biochemical pathway of anaerobic degradation, and we have seen that mainly 6 steps are involved in the anaerobic process, and 3 groups of microorganisms are present in the system, and depending upon the nature of the organic matter, either hydrolysis or methanogenesis can be the rate limiting step. So, by knowing the organic matter and the process, we can design the system effectively.